back to our class. Okay, we will talk about the derivatives of the inverse function. We conclude this section by investigating the relationship between the derivative of a function and the derivative of its inverse. Consider first what happens to a line L1. Here, L1. When it's reflected across the line y is x. As the left half of figure 7 makes clear. Here, this is L1. L1. When L1 as the left half of figure 7 makes clear, L1 is reflected into a line L2. This is L2. L1 is reflected into a line L2. Moreover, their respective slopes M1 and M2 are related by M2 is 1 over M1. Here, we can prove it. We choose 2 points AB and CD, so we can find the slope of L1. We learned last semester. This is the M1 here. M1 is equal to D minus B over C minus A, right? We have 2 points. And L2 AB, we find a new point is BA on L2 and DC on L2. So we find M2 is equal to C minus A over B minus D minus B, right? D minus B. We have these 2 points. And so we find M2 is equal to 1 over M1, right? 1 over M1. If L1 happens to be the tangent line to the, this is, we put M1 is not 0, but for this the straight line, for a curve, this is L1. If L1 happens to be the tangent line to the curve of F at the point CD, okay, L1, here L1 happens to the tangent line to the graph of F at the point CD. Here, this means this is a straight line. It happens to be a tangent line. Happens to be a tangent line. This is the tangent line to the graph F. L1 happens graph of F at the point CD, and then L2 is the tangent line to the graph of F inverse. F inverse. Happens to F inverse at the point DC. See the right half of the figure 7. We are light to the concluding that here, because L1 is the tangent line of Fx at the point CD. At the point CD. So, what's wrong? What? He's writing? He's writing what? He has a question? What's the question? Is the graph depend on no, we just first give this straight line, and this means it happens to be the tangent line of this curve of L of this curve at the point CD. Okay. The graph is relationship. It has relationship with respect to the slope, but it's not only depend on M. The graph depends on what? We just give one, just like this. You can think of like this. This is just, we suppose we have a we just suppose we have for example, this is a curve, right? This is a curve. This is a curve, and for example, this is the point CD. The point CD, for example, this area is just the slope, just the tangent line of this curve at this point, right? We can have tangent line, but here this is we first give the straight line L1, and this straight line across CD. And then we suppose this straight line is the tangent line. This is the tangent line of this curve at the point CD, right? This just this relationship between there. Okay. We just suppose we have a curve like this, and its tangent line at the CD is L1. Do you understand that? Yeah. And then we have another curve. It's at point CD. And L2, we just L2. Then we have L2 is the tangent line to the graph of F inverse at the point DC. This means this is one curve. Here has the straight tangent line at the point CD, and the L2 we have this curve is a reflection to the graph of this one with the y is x. Then we have L2 is the straight tangent line of this curve. So we know the slope. If the equation of this curve is y is fx, we have the slope of the curve. The slope we learned it in the last semester is f prime x, right? F prime x. So we know L1 has a slope. L1 has a slope is m1. M1 we write this is f prime x, right? F prime x at which point? You know, at the point this means x is c, right? X is c. So it's equal to f prime c. And we learned L2, the slope is m2. Okay, the slope is m2. And we know the curve, the equation of this curve is y is f inverse x, right? Y is f inverse x. So we have m2 is equal to f inverse x prime, right? Prime at which point? At DC. With this means x is d, right? X is d. And we write is equal to f inverse d, f inverse d. And we have m2 is equal to 1 over m1. So this means f prime c, f inverse this prime. F inverse d prime is equal to 1 over f prime c, right? 1 over f prime c. We put it. First you should know if we have the equation of this curve and the slope is f prime x. If at the point c, so the slope is f prime c. The slope at this point is f prime c. And we have the equation of this curve is f inverse x. So the slope at the point DC is f inverse d prime. And we know f2 is equal to 1 over m1. So this means f inverse prime d is equal to 1 over f prime c. We write this F inverse, this is the symbol. Okay, prime, the derivative at the point D is equal to 1 over F prime C. Right, 1 over F prime C. So we have this. We are right to the conclusion that F inverse prime D is equal to 1 over F prime C. Okay, and now you should know this C and D here. C, the point CD, we have the relation. They have the relationship C and D, right? CD, we know CD is on the curve. We know CD is on this curve, on this curve, right? On this curve. This means CD satisfy FC is equal to D, right? Because it's on this curve. So C and D has this relationship. Okay, you should know. And then we have F inverse from D. Here, this is D. How to find D? You should know what's C. And you calculate FC is equal to D, right? So F inverse prime D is equal to 1 over F prime C. 1 over F prime C. You should remember this formula. And then next we will have one example to calculate from this we have theorem B. This is inverse fraction theorem. We have if f be differentiable and strictly monotonic on an interval I, and prime x is not zero at a certain x in I. Then this means if f is differentiable, we have f inverse is differentiable at the corresponding point y is fx as in the range of f. And then we have this f inverse prime y is equal to 1 over f prime x. And here we just replace from the last example, we have f inverse prime d is equal to 1 over f prime c, right? We just replace d as a general number y and replace c as a general number by a general number x. So we have this one. And the conclusion to theorem B is often written symbolically as, we know, f prime x, we learned the symbol, we have many forms for derivative. One of is f prime x, we can also write is dy over dx, right? So the left side, 1 over f prime x, we write is 1 over dy over dx, right? 1 over dy dx. And the left side is f inverse, prime. F inverse, f inverse, we know this is y f inverse x. So we write this is 1 over dy over dx, the 1 over dy over dx, and we calculate it. We find it's equal to dx over dy. It's just like 1 over 2 over 3 is equal to 3 over 2, right? So it's dx and dy. This means we can write dx over dy is equal to 1 over dy over dx. Okay, I should know this. And we have, this is the last example. Example 4. We have y is x4, x5 plus 2x plus 1, and find f inverse prime 4. Here we find f inverse prime 4. We see now here, f inverse prime d is 1 over f prime c. This means d is, right? This means d is 4, right? The d is 4. It should be 1 over f prime c, right? But here c is unknown, right? Here is c is unknown. If we know c and we know how to calculate the derivative of f prime x, then we can find F inverse prime 4, right? So C is unknown, C is unknown, but we know the relationship between C and D, right? C and D. I just write in the front. C and D, we have FC is D, right? So this means FC is D. FC is D. We have this is FC. C, oh, okay, C is unknown, is D. D is 4, right? D is 4. This means FC is equal to C power 5 plus 2C plus 1, right? This one is equal to 4. So we solve C is equal to, this is a higher power equation, but we can guess it. C is equal to 1. We can guess C is 1. We can check it. C 1 plus 2 plus 1 is 4. Right? So this means we get C is 1. And when C is 1, we find it's 1 over F prime 1. Right? 1 over F prime 1. And F prime x, from this F prime x is 5x power 4 plus 2, right? So F prime 1 is equal to 5, 1 power 4 plus 2 is equal to 1 over 7. Right? 1 over 7. And questions for example 4. Last line. Oh, this right, we can't directly, I know your, we just, this is not calculation, we just, here we just choose a test point to get this C, right? Because I explained this equation has a higher power, right? The power is 5. So I also don't know how to solve C. We just have a test number C. I just choose C because it's easy to test the C. C is 1. 1 power 5 plus 1 plus 2 times 1 plus 1. We check this 4. So it's easy to check it, right? So, but for this equation, right, it's hard to solve C, right? We just choose a point 1, a test. Just try to find it, C. Try to find the test point, C is 1. So C is 1. Okay, and questions? If no, bye-bye.
白老师。Full time.